Today we're gonna have an exciting lab. We're gonna talk about RAG, Retrieval-Augmented Generation, which is a way to control the flow of your chatbots, of your AI systems based on generative AI. So you can take your documents, your context, and then answer based on that, because you know that in many cases, big LLMs such as ChatGPT, Gemini, BERT, and many others, they are trained in the past and they don't have the real-time data, especially our data, for example, the data inside of our company, inside of a project. So it becomes pretty difficult to manage the way to answer the questions regarding the new data that you have. And a RAG is a method to achieve that. So we're going to build the RAG from scratch using open source technologies. For vector database, we're going to use a pre-made vector database, but we can also use, and I'll show you how to use open source one as well. So yeah. And for today's session, we are going to code everything inside of Google Colab. I'm going to share the two links with you right now. One is a workbook that is an empty one. I'm going to share the screen with that. And the second one is going to be a solution, so you can follow along if you don't want to code along. Some people are just easier to follow along the code and later program themselves. So you have both options today. Okay. And please use a chat, use your mic whenever you want to ask a question. I'm going to catch up with you every single time to see if you caught up. And yeah, so let's get started. Okay, so first notebook that I want to share with you is a workbook. Just let me create my sharing link. Great. So please use this link here found in chat. So this is a workbook. And then the solution one. Okay. And for people that are listening the recording afterwards, you're gonna have these links in the comments of this session. This is a solution. Okay. Let me share my screen. Great. Okay, can you see my screen? Okay, cool. So the technology that we are going to use today primarily aligns with HuggingFace. And for you that never used HuggingFace before, it's an open source library that goes like this, huggingface.co. It allows you to use many different models regarding computer vision, image processing, natural language processing, audio, tabular data, anything regarding AI that you can think of. Hugging Face is currently covering, and everything is open source, so you can go inside each of the model and understand what's going on. And it's really important because you can build the whole system that we're going to build today, and we are going to build a system for medical data. So I'm going to explain why medical data in a second. But basically, you will see that you can build it without paying any third-party providers such as OpenAI, Google, Microsoft, or any Amazon or any else. But you can also host it for your private data inside your home. And by the way, I did it. So my smart home system is built on a similar system that we're going to build today. So I can chat with my smart home without actually putting the data outside on the internet, which is amazing. And I can control many devices like this light and stuff like that. Okay. For today's session, we need to use GPUs. And to activate the GPU inside of your Google Colab, you can go to Edit and then select the notebook settings. And it will create this pop-up for us. And you can choose this T4 GPU. Here I am on the free version, so you should have these for free as well. Just click Save and Connect. it will start connecting, and you will have the version of notebook with the GPU, which is amazing, for free. You don't have to pay anything extra. Now, the first step for us is to handle libraries. We need to install a couple of libraries to be able to work with these amazing transformers and models from HuggingFace library. And for that, you can click write exclamation mark pip install datasets and then space transformers. We are gonna install we'll install these libraries as we go along, so we don't have to install everything at once. So we just 2 libraries right now, and later potentially a couple of more. These 2 libraries are here for us to handle the datasets, potentially in the future, and transformers is the HuggingFace library. It's not called HuggingFace, it's called transformers, where you can take any of the models from their repository. Now, for you guys, if you're installing this for the first time, you might need to restart your runtime. So if that happens, like for example, if you try to import datasets and it throws an error like datasets does not exist or something like that, which is completely okay. In that case, go to runtime, restart session like this, click yes. You don't have to go again and set up the GPU. It will stay as it is, and you don't have to install this anymore. So just execute this cell and it will work as pleased. Okay. So we installed a couple of data sets that that are really important for today's session, and we need to import them right now. So for the first import that we need is tqdm.notebook import TQDM. Now, TQDM is a library that will create those loading bars for us. Okay, so when you load a huge data set or you work with a model, you have those loading bars, like green ones or red ones or blue ones, depending on which version of Python you use. But it is automatically created for you visually, so you know how much time is ETA. And this is the first import. Then we need to import NumPy, import pandas just in case. And I think that we are fine for now. Okay. Now, we are gonna import more and more libraries as we go along, and I'm gonna explain each of them as we need. Now, the next segment is to handle the data set. I'm gonna explain the data set and let you catch up, and then we can continue. So the data set that we're gonna use today is called medical text. It's a really simple data set. I found it on Kaggle. So Kaggle is a free website with a lot of data sets that we can just simply download. So please click on the link provided inside of your workbook. You can go to this exact page and click on download button. Some datasets will require you to sign in or sign up if you don't have the account. So just click sign in or sign up, depending if you have the account. I'm going to use my private email, and we are basically done. Click download again, and you will have a file called archive, and then without this 12, because I have many archives, that's why I have this 12. Now, when I do this and open this archive file, you will see 2 files. One is called test.dat and the train.dat. Now, these formats are a bit weird, and unfortunately, my computer does not know how to handle them. And to handle them, just click rename or enter, and then instead of this DAT, just write txt. It will ask you to do you want to keep this extension or change it? I want to change it. And I'm going to use the same technique for training set, use txt, and we are prepared. Now, if I open this txt file, you will see that it's a bunch of text regarding some medical terms, situations, and stuff like that. Okay. And now, before we continue, we need to have these two files inside of our Colab notebook. So to achieve that, I'm going to switch to the Colab. And on the left side, I have this folder files icon. Click on that one, and you will have this side menu pop up. Just select these two and drag them in here. You will have this warning that will tell you, hey, unfortunately, this is a temporary session. So once we close down this window or session, your files will be removed and you need to re-upload them again. That's a bit boring, but that's how we work for free. Okay, so while that happens, I'm going to leave you up to that to do it yourselves. So we all have downloaded the data set. So please let me know if you have any questions or need help regarding this part. I can just close this and similar to edge computing. Can you please explain a bit more your question? Yeah, I want to answer it, but I need more context.
So you mentioned that you've set up your smart home system on a separate, right? So I just wondering, like, just the application of edge computing, right?
Everything is running. I have a computer down here. I can potentially, it's a mess, but I can show you with a camera later at the end of the session. There is a server which is running 2 GPUs and a lot of RAM to run my home AI system, basically. Yeah, it's another.
Sounds nice.
Yeah.
Definitely, I'd love to see that. Thanks.
Yeah, Alexander, he asked the question, for my smart home solution, what did I use? Is this similar to edge computing, or I have basically some other solution? And then I went to explain what solution I use. Guys, have you managed to download the data set and upload them to your Colab environments? Please let me know if I need to repeat some steps on how to achieve that. Just give me thumbs up or yes or whatever. Cool. So let's continue with the data set. Okay, this is a solution. We need this one. Okay. So before we load the data set, I want to explain a bit more about the RAG. What is the goal that we are trying to build? Well, so when you have an LLM, any LLM, it can be GPT, it can be Llama 3, it can be Chinchilla, it can be Llama 2, it can be Gemini. Any model that you might think about generating text, even BERT, the oldest one, it's trained on a bunch of data that stopped at some time in the past. So for GPT-4 or 4.0, it's a December of 2023. I think they moved it to April 2024. I'm not sure about that, but I think they moved it to April 2024. And it's really expensive to constantly train it on every single day. And it's basically impossible to some degree to finish the cycle of training every single day. So what that means is if you have a certain data set or a data point from your company that you want to put inside of the systems, it's basically impossible to capture that and reproduce it through generation. And it becomes infeasible for companies to build their own internal systems like chatbots, supports, assistants, knowledge retrieval, and stuff like that. And then people created something called RAG, which is called Retrieval-Augmented Generation. What it means is basically this. You have some base LLM that was trained on whatever amount of data to whatever task or a data set that you had. It might be a general one, such as GPT or Llama 3, or it might be a more specific one for code, for example, Code LLM or something like that. And now, before you produce the prompt and then produce the output at the end, you need to prompt it with some kind of information that is real time. And for that, what we do is basically have a database of documents. And those documents can be books, code, text files, PDFs, PPTX files, anything that you might think of. Those files are generated in past whatever amount of months, days, minutes, whatever. And then for each of these documents, what you do is basically create a single vector. A vector is a representation, just a list of numbers, and you will see that in action in a bit. And after we have that, what happens is basically what we do is with cosine similarity or some similarity metric that we're going to cover. So if you don't understand it right now, don't worry. We check all the documents in our database and say, what is the most relevant document to the question that the user asked? So user asked some question, and then the question goes and see, hey, is there some document that might answer this question? And what we do is we prompt it with a system prompt like you are a helpful assistant or whatever, and just add the text from the document at the end. And this is this relevant document. And what we do, we have a prompt that we wrote manually, plus a set of documents added on top of that, and then produce the response back to user. So what we say in the prompt engineering sense, we basically say to GPT or any LLM, please use the context from the documents to respond on this user query. And that's how this system works. So to achieve all of this, we need to build a couple of things. We need to load the documents. That's what we are going to do right now. And after that, we need to build a system to encode these documents in a way that we're going to explain. And then you need to push it to some prompt and then respond back to us. So that's our goal. So we have 4 or 5 components to build in this video. Okay, so let's see if there are any questions. Not for now. Okay, so I need to install something called LangChain before we continue. The first step is to install that. And here I'm going to write exclamation mark pip install LangChain. And LangChain, while that happens, I want to show you this link. So I'm going to open a new tab. LangChain. And LangChain is a big library of a lot of techniques that allows us to work with these models, like open them, load them fast, load the documents, and then basically create these RAG systems in no time. LangChain. And LangChain, which is amazing, supports natively. It doesn't want to open the new tab, but basically LangChain supports natively HuggingFace. Okay, here it is. Okay, so you see it's LangSmith, the enterprise DevOps platform built for LLMs. And here it is. So allows you to open and use basically any of the models in no time. My computer is lagging for some time, for some reason. I'm not sure why. Okay. Good. So this is what we're going to build, and it's completely free. You don't have to worry about costs and anything else. So once you have this installed, you need to import a couple of things, but before that, we need to open the text. So we have two text files, train.txt and test.txt. We need to simply load the text file. So write with open train.txt read format as file or as f, and then say data is equal to f.read. And with this, if I show you the first 100 characters, you'll see that it is a bunch of medical data that for me doesn't mean anything because it's medical data. And this allows us to load the data set. Now, your question might be, okay, but why medical data? Well, most of these big models were never trained on medical data, medical books, information, or even if they are trained, they are restricted not to answer those questions because those can be a bit problematic towards people that are just taking for granted or just taking like on the face of the note without checking twice, and yeah, basically never checking the response if it's correct or not. So medical information is a bit restricted in these models, and if you want to build one, you need to provide it with your own data and your own kind of set of actions or set of commands. And that's why the medical data, because we will see the biggest change once we have this system built. The next step for us is to load something called LangChain document. So from LangChain docstore document import document as LangChain document. Okay, so here we are importing docstore document. Document object is basic object from LangChain to open a document and store it in their own document object so we can start working with it. And I just give it a name, a LangChain document, just so we know it came from the LangChain. And here I'm going to create a new tab and write raw database is equal LangChain document, and then just provide page content is equal to data, and it will take the full data set that we loaded from the file and load it inside of this LangChain document object. And we are basically done with loading the data into this object. Now, this is going to be important in the next step. For now, just execute it, and I'm going to wait for a couple of minutes to see if you caught up and if you have any questions. Okay, we have two questions. What is the practical limit to RAG related to the typical context window of a LLM? Great question, Lino. I'm going to go back to that. And are you going to make something like chatpdf.com? Yeah, basically, we can build a chatpdf.com without any issue. So the exact same steps are needed to build the chatpdf.com or pdf.ai. Yeah, basically works the same. And for practical reasons, RAG saves money, and allows you to have a much bigger or larger data set instead of the context window. So for some models, the context window became so large that you can put up to 1 million tokens inside of it. And for those models, the best bet would be basically to put all the context inside the context window. Now, unfortunately, those models either require a lot of computational power, so you need a couple of GPUs to load it, a lot of RAM memory. It costs a lot of money to build or rent those computers, or you're going to pay a lot of money for those requests if you're going to use the service connected to some of the provider like Cohere, OpenAI, Microsoft, and stuff like that. So RAG actually decreases the amount of money that you're going to spend or the resource that you need to load these models. Instead of loading 70 billion parameter model, we're going to work with a 7 billion and still achieve amazing results. So those are practicalities of a RAG versus context window. But if you compare I would say the lacking point, the context window will always work better than the whole RAG because everything is inside of the context window and it will work faster than RAG. However, the breaking points are the performance when it comes to money and the performance of the availability of resources. So yeah. A lot of my clients are actually using RAG and they're really, really happy about it. Yeah. Okay, guys, have you caught up, loaded the data set, created the LangChain document? Do you want me to go back so you can copy that part? Okay, Salma, you did it. The rest of you guys?
Yep.
Okay. Great. Okay, so now there is an amazing part that when it comes to building RAGs, and that is how are we going to manage these documents? And this is where you will have a lot of time to learn and see many different techniques on how to manage the documents. I'm building up to it. So we talked about, Lino asked an amazing question about context window. So for the most of the models, your context window is not 1 million tokens. It's basically 16,000, 32,000, 64,000 and stuff like that. And if you have a book, a large book, you can't push the whole book inside of the context. So you are some kind of a limited to amount of text that you can put. And that's where the chunking comes into play. Okay. So instead of putting the whole book, you're going to split it to different parts, chunks, and then you use those chunks to fill in the context gap. Okay. The chunks are generally 1,000 to 2,000 letters, characters. So let's say like this would be data, this will be our chunk. Okay, so this would be a one chunk, and then the second chunk would be so first 1,000 characters will be a single chunk, and then the next 1,000 characters from 1,000 to 2,000 the next chunk. And this is how we gonna process these documents. So instead of putting the whole file in the system, we'll have as many chunks as needed to reach these many of the tokens or chunks of 1,000 letters, and then basically use those to build the context for our LLM. Okay, so that's our goal. Now, luckily for us, we don't have to split it in this way because it's not scalable, or sometimes it's not really nice because as you can see here, we are splitting the word in a half, which is not nice. And to achieve that, you have some chunkers. So even you have semantic chunker, I'm going to cover that at the very end, but you have a letter chunker, you have a chunker, like if you go and say LangChain chunkers, you will see that there are text splitters all over the place, and you will see that there are many of them that you can experiment and see what performs the best for you. So you can split by character, you can split code and markup to make sense. You can split contextually, so what works together the best, which is called semantic. You can use a custom, you can do recursive, which we're going to use. And all of that is there to allow us to split these big texts into smaller parts so we can feed one part at a time to our LLM. So for today, we're going to use this recursive split that uses the new lines, that uses a new page and all the marks that might be indicating the end of a certain part of the text to split into those chunks. And then, of course, we split on the amount of letters that we provide. So because of that, we won't have this breakage at the middle. For that to achieve, we are going to use from LangChain text splitters. You don't have to install anything for this. This is automatically installed by installing LangChain. Import recursive character text splitter. Okay. And here I need to define my splitter. Okay. Recursive splitter. And these are all the things that we need to provide. So the separator are these separators in here. So here are all the new line and the new page characters that we need. So for example, new line and then nothing, and then some hashtag symbols after that 1 to 6. Then new line, and stuff like that. So if we have these at the end of 1000 characters, we're gonna split. So here, the first argument is called separators. And for that, I'm going to put markdown separators. The next is chunk size, which is 1000, as we said. Oops. 1000. And here, I'm going to provide add chunk overlap. Chunk overlap of 100, which means that instead of just splitting on 1000, we're going to take a bit of more, like for example, the last 100 characters. So we have context in between. So it's not like this and this, but we have like overlap like this. So these parts are repeated in both chunks. And that actually increases the accuracy a lot. So you can just execute like this and it will work. So you don't have to provide any other arguments, but you have a couple of them inside of your solution notebook that I have here open for you. But for us, just for sake of demonstration today, you can just execute like this. And if you go to splitter, now we need to call the split documents. So split documents, and then provide a list and raw database that we provided. So let me do this, and then I'm going to catch up with you to see what's going on. And then here, processed data, for example, execute that. And let's take a look at the first one. Processed data. The first one, you'll see that it actually follows what we wanted. The first 1000 characters as we said. So basically what we did with that data of 1000, but it actually didn't cut it in half. It actually included the full word. And if I take a look at the first one, you will see that it actually didn't cut in half, but it actually used the full word. Okay, so that's basically how you split your documents in the most simple way on how to go from a full document really fast in bunch of chunks to achieve this. So let me see if there is anything I can help you with, and if you manage to understand everything so far. Please let me know if I need to repeat something or go into deeper part on some part of this. Okay, let me know, please. And let me know with a thumbs up if you're all caught up. Okay, cool. Great. Okay, so we have our dataset actually prepared. We are almost done with this part. But before we continue, we need to install two more things so we can start working with our tokenizer and vectorization of the whole dataset. Now, to achieve this, I'm going to install two things. Pip install LangChain _ community. And the next one is pip install sentence transformers. Okay, and when you execute these two parts, it will install in like 20 seconds. But what these two libraries are doing, the first LangChain community allows us to import something called HuggingFace embeddings, which allows you basically to immediately use HuggingFace to solve the next step, so we don't have to code like 100 plus lines of code, which allows you to save a lot of time and, of course, repetitive work. The sentence transformers is another library from HuggingFace that is focused basically on encoding and processing sentences and text with specific amount of models, so specific types of models, like big LLMs and stuff like that. And for this, we need these libraries. So because this one is using this in the background, we won't use this explicitly. It will happen under the hood here. Okay. So if you don't install this one, it will yell at you and say, hey, you don't have this installed and so on. Okay. While that happens, I'm going to switch to the next slide. Everything is successfully installed. Amazing. Okay. So the first step is to import from LangChain community, okay, dot embedding import HuggingFace embeddings. Okay, HuggingFace embeddings, the last one, HuggingFace, the second one here, embeddings. And you can execute. Now, we have here something called model name. You can name it to model name like this. And now your question is, where did I find this model? So if you go to and just paste it inside of the Google, you will see that, of course, we can't find it like this. But let's go again and go to google.com. Okay. And this is a name of a model for embedding our data inside of a HuggingFace library. So here if I go to Google and just search for this, you'll see that Hugging Face pops out as the first one. The first part is a username, and the second part is a name of a model. You can name the model whatever you want, and the user can name their account, of course, whatever they want. Now, this is some user created a model called GT small, which works flawlessly for what we want, and we want to create something called vectors from our text. Now, let's go back to our workbook and do it exactly what we want. And I'm going to explain step by step what actually happened so you can follow along, and then we can continue. The next step will require a couple of more things. Because we are a bit more over the time that I wanted, I'm going to copy this larger part of the code, paste it, and explain it. So from the solution, when I scroll down, I'm going to copy this part in, not this one. Okay, so let's use this. Great. Go back to workbook and just paste it. So what's happening here, of course, my model name is not yelling at me anymore. Okay, so let's use this. Okay, so we are creating a Hugging Face embedding, which will take a text and produce a vector or set of numbers, list of numbers. Then I'm going to ask and say, okay, I want it to be multi-process because we want to get vectors really fast. And I want the device to use CUDA, which means use please GPU because it's going to be faster. Now, encode quarks, normalize embeddings is equal to true if we want to use cosine similarity, because some models will require you to have crazy amount of numbers by default, while some other models will allow you to normalize them, which basically divides them by the maximum, so we can use cosine similarity. Really simple. And let's execute. Model name is not defined. Model name. Did I execute this? Let's try again. And let's see. I think that's it. Okay. While that goes on, it will take some time to download this model. So you can see it will take about 10 seconds. After that, you can call this embedding model. Now, embedding model dot, and now you can do something called embed query and just provide text. So here, hey, I am testing this model. What's gonna happen is from this text sentence, it will take about 15 to 20 seconds, depending on your GPU. You will get a bunch of numbers. These numbers don't mean anything for us. These are just the random numbers, but it will mean a lot to our model once we get to comparing, like, for example, our new question to the existing ones. Okay, and with this, we got the first step covered, which basically allows you to transform all of the data inside of this. Okay, I got restarted, so let's see how you process. Yeah, looks like a data source in Kaggle has only that and CSV. Okay, how did you change? I just basically used the extension. Yeah, I just rename it that and remove that to text. That's it. Yeah. Then we have a question. The first question, Alexander asked, why did you select this particular model? Embedding model is also possible to fine tune. How do you know whether embedding are good enough? Amazing question. I'm going to answer that in a second. What's your rule of thumb when to use RAG and when to fine-tune LLM to domain specific data? Great question. And do you have a good intuition resource to read about normalizing embeddings, or can you elaborate a little more if it was not clear? Great. Let's answer all of them. Please let me know if you got all up to speed for the code while I answer these questions. And if you need any help regarding the code, please let me know. So the first question was, how did I select this model, or why? And basically, how do we know whether or not those embeddings are good? So I read a couple of blogs in preparation to this workshop or a lab, and then I found out about this model that fits inside of the RAM of Google Colab. So I was pretty much restricted with the Google Colab RAM because it is a small RAM when you load a LLM and this model. So I tried a couple of them, but it always fails because of the lacking of the memory. So I ended up using this model. That's the one reason. The second reason being this model is based on the previous Llama 1 model and Llama 2 models embeddings, which is just fine-tuned by this user, and it worked pretty well. That's basically it. Now, to lead to the second part of your question, how do you know that embeddings are good? Well, I always use a couple of models if I'm not restricted by technology. So sometimes my clients will go and say, hey, you need to use OpenAI or you need to use Gemini because of our tech stack, or you are restricted by these and these parts. Once I have that requirements, there is no much research to be done. So I just need to follow along what they wanted. But in the case when I'm building a system from the ground up, I always try 10 to 12 models, 20 models sometimes, to experiment and see what actually retrieves the best results. And how I do it, I implement, I select the same piece of content to be in part of my database, vector database, and then I just ask questions and I get it or not. I'm actually building a system right now for one company. We built on one model, open source model for embeddings. It does not work for retrieving any data. So we are now switching to closed source model from Cohere to experiment with that one. But the current implementation did not retrieve anything. Yeah. So what is my rule of thumb? I fine-tuned LLM maybe once, because fine-tuning LLM does require more resources and more data. So a RAG does not require you to do anything regarding the weights of your LLM. You are only working on top of it to prompt it. So if you have more niche data, like a couple of gigabytes, maybe terabytes of data, I would definitely go with fine-tuning. But if you have a couple of files and data that can be put in maybe 100 pages, 150 pages, go with a RAG. Yeah, it works good up to 500 pages as I experimented. More than 500 pages makes really messes up the whole performance. Normalizing embeddings. So let me find this. The third question was to read about normalizing embeddings. You can open the basically any documentation from HuggingFace, for example. But basically, what's going on? You get some, let's say, number, for example, this number from the LLM is just a random number, and what they do is basically divide it by the maximum number. Okay, like this. And then you get normalized embeddings across all the pieces of the vector. Yeah, it does work just like that. So nothing special. You just ask, what do you want, the raw numbers, or do you want to divide all the numbers by the maximum amount of maximum weight or maximum number? There is no magic there. It's just dividing with the maximum. Yeah. Okay. So let's continue. I got a lot of thumbs up, so I assume that you already finished up to this part. Okay. So the next part is to store the data inside a vector database. Now, there are a couple of options. You can use something called FICE. Okay, so let me open the new. Okay, FICE. FICE is an open source by Facebook library for searching vectors. However, this library does require you to store all these vectors locally. So if you want to handle that locally and then load it per need or prompted, I do recommend FICE. However, it does require more resources and more management and coding from our end. Now, for today's session, I'm going to use something that I use for my clients all the time called Pinecone. And Pinecone is a product basically to store your vectors. It's completely free. It can cost money, but for today's session, we're going to have everything for free. And I'm going to load on one of my accounts, and you will see that actually I have a lot of clients on this account as well. So let me log in with my Google account. And you will see right now that, come on, please log in. Okay. Something went wrong with their server, of course. So let's refresh. I have a backup if this happens, but basically, I don't know why their server decided. Let's try again. Okay. I'm not sure what's happening with my computer. It got pretty laggy. I didn't explain that part just yet, so I'm gonna explain that part why we are using this in a second. Just let me see if I can connect to the internet. Oh, makes sense. Makes sense. Yeah, but it didn't want to open any page. Yeah. Okay. I potentially will switch to the other laptop because this one got really laggy for some reason. But let's see if we can pull it through. Okay. And now it should work. I don't know what happened before. Okay, cool. So with a Pinecone, you're working with indexes, and each project, for example, as you can see, I have many projects opened in here. You will have an index that you can create. So I'm going to create an index for us right now, create an index, and we're going to finish the installation or creation of this index in a bit. But we got an amazing question, and with what is basically, why are we using Fice or Pinecone? So to store, you will have thousands and thousands of vectors that you need to store somewhere, so you can actually check which part of document is actually relevant to the question that a user asked. So you need a database, basically, of the vectors that you're going to store. And you can either use it locally in a RAM, or you can use it some software or a solution like a Fice or Pinecone, basically that. So Fice is something that you need to host it locally on your computer or a machine, and it's working the same way as Pinecone. Or for Pinecone, you don't need to install anything. Basically, you just use it because it's a product, and you store all of your vectors inside of that product. So whatever you decide, that is a kind of a solution. Now, Alexander asked, when there is a lot of text data, do you measure embedding performance somehow? Yeah, I do, and that is generally done by user testing. So we have, like, for every single kind of a solution that we are building for a client, we have a certain goal that we want this agent or system to achieve, and we for user testing we have about 1,000 questions that needs to be answered with the data. Okay, and that they provide the data before we create those 1,000, even sometimes more questions, and then a lot of stakeholders from those companies are actually reaching and asking this system to retrieve some data, and we basically get if they got the right answer or not. And then we iterate and then do this basically for a couple of times until we reach the point where most, if not all, of those tests are suffice. So it can be a couple of weeks, sometimes months to reach that point, but we are doing that. So user testing in a loop, basically. Yeah. That's when you have a specific business problem you're searching for or handling. Yeah. Do we have to adjust the chunk size to specific embedding model? No. Basically, chunk size, I did work with all the models that were mentioned previously, but chunk size were varying from a couple of more than tens of pages of book. The only difference there is basically whether or not you have provided the context in one chunk that's enough for a model to understand. So chunk is basically telling you, do you have all the information to answer the question or not? Yeah. So when I go back to my Pinecone, I'm going to create and say lab rag index. And here dimensions is basically how many numbers do we have in our vectors. And you can go back to your notebook, and here we have the one example. What you can do is put here in the side len, oops, and execute again. Okay, maybe it won't work for me because my my notebook got restarted, but it works. Yeah, 384. So if you go back to creating a new index and you have this setup by model, you have already provided a couple of models with their sizes. Now you have a Mistral, you have embedding by OpenAI, you have Cohere, you have Clip, you have all other models that were an option to create embeddings. For us, we need this one because it's 384, set configuration, and the rest you don't have to touch. Just create an index, and it will take 10 seconds, even less, to create an index. And here you see that my lab reg index, which is completely empty, is online. So to connect to it, I'm going to click connect. And the first step is to install Pinecone. So here, let's copy this part and go back to my notebook. I'm going to put here exclamation mark pip install Pinecone client. And while that happens, I need to copy more code. So from my lab reg, I'm going to copy the next step, which is initializing. Copy. And go back here in my reg workbook. And here, I want to copy and initialize this. Now, this quick start is not something that we need. We need a name of my lab or my index, which is lab reg index. As you can see here, lab reg index. And I'm going to execute that, and I'm connected. So right now I can put data inside of this index, inside of the database. Now this API key is going to be your API key, of course. You can copy this one and try to use it mine, but I'm going to remove and change API key after this lab. So yeah, basically that. And the next step is to push the data inside of this Pinecone index. To achieve that, what I'm going to do is called data to enter, to add or something like that. And that's going to be empty list. Then I'm going to put I, comma, entry in TQDM enumerate, and then my data, which is, if I go scroll up a bit more and more, come on, process data. Okay, process data. And here, I'm going to put it here. Okay. So for each of these, I need to create an entry for my data to add. Okay, so how to do that? Well, the first step is I need text, the pure text. And that's going to be entry dot page content. So how do I know this? Well, if you take a look at the first element in our processed data, it will be a document from our LangChain. And then I can go and say page content to get pure text. Okay, here it is. Okay, we solved the first part, which is a text. Now we need a vector. And for the vector, and which is a list of number, vector is equal to, so our embedding model dot embed query of text. Okay. And then I'm going to use data to add dot append. It's going to be a dictionary. And the first dictionary is going to be ID, because this is a database, so it needs IDs. And it's going to be vector underscore, and then I'm going to provide a format of I, which is my index. Then the second step is values, and these values is our vector. And the third one is metadata. Okay, and this is anything you like in the key value pair. So here I can provide text and text. Okay, because this process data, when you check a length on how many elements we have, it's going to be like 25,000. It's going to take like a full day or more to process. We don't have full day, so let's use maybe first 5 or something like that. So I'm going to process all the data, and while that happens, I'm going to answer all the questions and see if you manage to do these 2 steps. Okay. Guys, how is it going? Have you managed to follow so far? Do you need any help? Please let me know. I can go back and repeat anything you like. It's not a goal to rush through, but it's a goal to explain anything that you might like. So there is a question. Rene asked if the context needed to answer our question spans a larger region of text, we need to increase the overlap. Is there a rule of thumb for this? Yeah, there is. So wait, I don't know if there is a rule of thumb, but what you can do to achieve that is to use a couple of chunks into your answer. So you basically can control on how many chunks you can provide at once to the model itself when it provides an answer. Yeah. So for example, maybe one chunk of 100 or 1000 characters might be too short to answer the question. So you can put like 2, 3 chunks at a time and answer the question by using all of that. I think I had to go back to the recording. I have missed the first and second step in between. It's not easy. Please let me know. I'll go back right now and answer. When you have more than one text to embed given by a client, the ID will not be unique. Am I missing something? IDs can be anything. In this case, I use the ID to be, that's a great point, by the way, Alex. So in here, I use the vec underscore some number. Because the ID can be text, as you can see, sometimes if I have multiple files, like 10, 15, maybe even more files, what I'm using here as an ID, name of a file, and then underscore ID or I, whatever. So I can use full name of a file. Like I had a client, well, not had. I'm still working on that client. This one, let me go back to my data to my index. So here, Delta Sapiens or Delta questions. Here I have about 1,000 of the questions, and those questions or chunks are coming from 25 different files. So IDs starting with the file name and then go further. As you can see here, we have our vector count increased because we pushed some of the information from our database, from our file to this, to the database. Yeah, thanks. Arpit, can you please let me know if I need to go back to a certain step, or do you want to go back to the recording and rewatch that part? Okay, yeah, no worries. I'm here to help. Okay, so now that we have all the files added to the Well, not added yet. What we need to do is to finish by doing this. Index, upsert, okay? And then just provide data to add and name space. You can namespace anything, but by tradition is NS1, namespace 1. And you will see that we have upserted 5 vectors. Okay. Now it's time to load a model. Okay. So the first step is from transformers, import something called pipeline. So pipeline will put all the steps in a one function, LLM, we'll call it LLM, that will take a raw text, process it, prepare it, and then put it through the model and give it the output. If we don't do this, we need to code a couple of steps together to achieve this. Because we have a pipeline, we can push it together. So, for example, tokenization, processing, then coming back to text and stuff like that happens all inside of the pipeline. So basically stacking a couple of functionality regarding LLMs into one. So the next, I'm going to import Torch, just in case, because all the models are written in PyTorch, and sometimes we'll need to have that explicitly pushed like this. And then again, from transformers, import auto tokenizer, then auto model for causal LM, and then bits and bytes configuration. Okay, don't worry, I'm going to explain. And the model name, again, is HuggingFace Zapier 7B Beta. Now, HuggingFace, as you can see, I told you the first part is the username. So this one comes from the HuggingFace team directly. So HuggingFace made it for everybody to use. This model in here is a pre-trained model called Mistral, under some different name because it's Hugging Face's model trained on their data, publicly available data, but their data set. 7B stands for 7 billion parameters because you have 7 billion, 14 billion, and 70 billion. So we are using the smallest one, okay, from Hugging Face. Now, regarding the imports, the Torch, I told you, and pipeline, you already know. Then you have auto tokenizer and auto model for causal LM. These two will allow us just to provide a name, and it will find through the magic of transformers and Hugging Face exactly our models and basically download them to our computer and answer. Now, the last part is a bit more confusing, which is called bits and bytes config. Now, all of these models are trained normally in weights that we all generate, maybe floating point 16, 64. And then what you have is maybe a weight that goes like this. Okay. And then you have a lot of these numbers after the comma, which is called precisions. So what you can do is basically change the last one to 4, and it will be a completely different number for a neural network, and it might change completely its behavior. That's normal. Now, if we do this, you will see that you need more space because this is requiring more space in a RAM or your computer to store these big models. And sometimes you can have these big models. Now, I tried to load this model in the Google Colab, and Google Colab broke down. So if you try to load this model without the next step, it will break down. It will break down. So what we have, a method called quantization. So you can read about quantization in many different sources. After the recording, when I provide links to these regs in the comments of the recording, I will provide an amazing read for quantization if somebody wants to go deeper inside of this topic. But basically what quantization does is after the training, it will take these big numbers and slice them to fit in memory and then do something like this. So instead of maybe 64 bits, you need now 8 bits to store this number. And that helps a lot because it sliced the full memory capacity by 8. Okay, 8 times. So you need to install 2 more libraries to achieve this, bits and bytes and accelerate. These 2 are again from HuggingFace that will help you automatically in a single line of code make from a big model to a smaller model that can fit inside of the memory. Okay, great. So we need to implement this config. Now, again, to preserve the time, I'm going to copy this config for us and then explain step by step. So let me go again and copy the whole thing. Great. And come back in here. Okay, so let me run this. So what's happening in here? Pip install accelerate. Yeah. Okay, I need to install this accelerate. But then I have this installed. Okay, so what's going on is it didn't catch up. So what you need to do, as I told you before, you need to unfortunately restart the session. So let's do it again. And then I need to execute a couple of more cells. Okay. Good. I'm gonna need to do this. And again, do this part. While that's going on, I'm gonna go back and create again this embedding model because we will need it later. Okay. So let me scroll right down, and you'll see here it will take a minute or 2 to install. So what's going on? Bits and bytes will take the first argument called a load in 4 bits, which will basically squish the whole number into just 4 after the precision. Okay, it will lose the accuracy, it does lose the performance. However, it will allow us basically to still run the model as it intended. Then these 3 arguments are there to quantize the model in a specific way. I won't go into details because we can spend the full lab just on quantization. After that, I'm going to load the model, like use this auto model for casual that we imported above from pre-trained, put a model name, and just provide quantization config to this config. That's it. Really simple, as I told you, in 1 line of code. And tokenizer is tokenizer that goes in pair with this model. We talked about tokenization in the previous lab. Okay. So it will take about a minute to finish. While it's coming up, let me see if you have any questions. Okay, we have a chat going on, so let's see. Okay, thanks. Everything is clear, but will you be hosting some webinar on best practice on how to put this into production? I know it's a general question, but I guess that there should be a guidelines to follow when starting from a sort of POC to need to deploy into production system. That's a great point. Yeah, we talked about putting that, and I'm actually writing a whole course on MLOps right now, which is going to be added to the platform later this summer. Yeah, so you will have the full MLOps course. And following that, I will host more sessions on providing general machine learning to production, to LLMs in production. Yeah, we can talk only about that in like 10 labs. How do you find an LLM that fits performance price ratio for a client system? Oof, that's a great question. I do read a couple of papers every couple of weeks, see what's there, loading like a lot of models from the HuggingFace and seeing what people are rating and using. So if I see that something is used a lot, it's actually tested. So I can test it myself and I see whether or not it's good for the battleground. Yeah, I don't have any good like I'm speaking about performance, speaking about the first part. The price, however, is I think more challenging part, where it actually dictates a lot about the model size. So for example, the price will say, okay, unfortunately I can't pay more than, I don't know, $50,000 for production machine. And then I say, okay, for that price I can build this machine with these capacities, and I can go up to 14 billion, let's say. And then they will say, sure. They don't care about that because they are not data scientists. I get the performance, and then basically the pricing system, and then based on that I'm choosing the model that fits inside their pricing range. The same goes for online, for on cloud production. They provide me with a monthly budget, and then I try to fit the best performance in that budget. Yeah, and of course I'll update them along the way so they understand what's losing and what's happening there. My data to add. Selma, yes. So let me go back to that part. Please make sure to have this added. Like I just used the first 5 rows, the first 5 chunks or whatever, because it has 25,000 chunks. If you leave it to run without pushing like the limit, it can run up to 2 days. Yeah. So please either stop it and start from scratch, but just use the first 5 or first 10, first 20. And that's something that's gonna stop it, and then you can actually test the rest. Yeah, of course. That happened to me, so I know the problem that actually happened to me earlier today. Yeah. Okay. So let's finish up. Now let's push everything together and create our LLM model. So LLM model is equal to pipeline, and the pipeline will take many different arguments. The first argument is going to be our model. We took our model from here. Now we need to provide tokenizer. It's going to be tokenizer. And then here task. So for task, you are specifying task as a text generation. Okay. Then for the next, do sample to true, which basically chooses a couple of different outputs and chooses the most likely one, or the best basically output for your question. Then temperature, that is as it functions to any LLM. So let's put it to 0.4 for now. Then for now, I won't add any more arguments, but you can play along with more arguments in the solution notebook that you have. Max new tokens. So which is max tokens, let's say 500. Execute this. And you have your LLM prepared. To test it out, you can just call LLM model, hey, what's up? Okay, we have one more cell to write, and we are basically done. Okay. So it will take some time because we don't have a strong GPU in here. But yeah. Please finish execution. Do we have some questions? Not yet. How are you guys going? Do you have everything done so far? Everything clear by now? By this point? Alexander, I will answer that in a second. Yeah, that's the next step. Yeah. Okay, everything done so far? Thumbs up, thumbs down? Do you want me to repeat some part? Yeah, Alexander. Yeah, it can be to save money, but generally it's basically when you're using APIs, it's to save money. When you're using your own like computer, it's to save time. Yeah. Okay, and we got. Hey, what's up? For some reason, I'm Jessica. Oh, I'm not Jessica, but somebody is Jessica. Okay, so this model is trained generally on different texts. Somebody has their microphone turned on. Can you please mute it, please? Okay, so we have our LLM working. It responded with some gibberish. It's not a great answer, but let's prompt it to see whether or not with the prompting technique we get better answer. So here is the prompt that we're going to use. We start with the system, and you are a helpful assistant that answers on medical questions based on the real information provided from different sources and in the context. Give the rational and well-written response. If you don't have a proper info in the context, answer I don't know. Respond only to the question asked. User, context. Here is the question you need to answer, question. So you're basically giving the context and the question from the user. Now, when you prompt it like this, in most cases, it will make up some crazy answer as you had it like this. However, if you have your system set up to answer based solely on the documents that you have, you want the temperature to be close to 0. So what happens with the temperature is basically telling it how random do you want this sampling to be. If it's a 1, it's completely random. So it's sometimes every single time that you ask some question, you will get a different response. If it's a 0, it will be more likely to respond in the same way for a couple of times. And when you are doing with the files like this, you want this to be close to 0. Now, you can put it completely 0, and it won't make any more information as it has in the documents. I like to put it to some number above 0, like 0.1, 0.2, so it still makes a response more interesting. However, it won't be far from the file that we provided. That's kind of some experience that I had. So prompt, you don't have to change. I just provided a prompt, and now it's time to put everything together in the interface. To save us time, so we don't have to go a lot more than this, I'm going to copy the last cell and execute. Okay, so what we got in here is really simple. We first ask a user a simple with the input to add the question, basically. And then we use our embedding model that we created at the beginning of the session, and we are creating a vector out of that user question. And then what we have here is basically getting the database and retrieving the most probable answer. So first question, the first part is namespace. This part needs to be the same as you put vectors inside of it. Okay, so if I scroll back and you see this, index upsert, namespace ns1, so this needs to be the same as this one in here. The vector is the vector that we are sending. That's our vectorized input from the user. Then top k is basically how many we want to retrieve. Do we want just one, which is in here, or we want multiple? We had a question on what if the context is more than one single chunk? Well, in that case, this top k will become maybe 5 or 2. Because we have only 5 vectors, let's keep it 1. Now, this part is important because we have include metadata. So include metadata will tell us exactly to retrieve not only the result, the ID, but the text as well. Because if you go to my index, you will see that metadata has this text, which is basically the part of our chunk. Okay. What I do next is I call the LLM model, but I use the prompt that we defined together in here, and I add context, and I add what is the question, user input. This part, user input, and this is a context coming from my Pinecone. And at the very beginning, I say, at the very end, sorry, I said print AI response generate text. So if I execute this, and just to make sure that we have coded it properly, I'm gonna take maybe this cardiological shock and then copy this. Come on. Okay. And say, what is this is lagging so much. Cardiological shock. Okay, so what's happening right now, I sent this to my embedding model. It will create a vector behind it, then use that vector to retrieve the most common or most likely answer to be, and then it will send to LLM to provide the final response to us, structured in a way that we actually get text from anywhere of the files, and on top of that, it will make it user-friendly. While that's happening, let me see if you have... Oh, okay. Everything clear, but I got stuck on the Pinecone key and prefer to pay attention to your explanation. I'll do over the recording. Okay, sure. Is the prompt for, from a specific format specific to the LLM, and where is it defined? Where is defined, you just saw in the file. Yeah. And the specific to the LLM, no. Any LLM should work with the same prompt. Yeah. I have a file where some information is incorrect. The data should be 00587, but it sometimes appears as 00578. Or do you know how I can cleanse this data and correct these errors? You could use LLM to detect those problems, like with, for example, templating thing. For example, if it's, but you need to provide exact exact example like you did here. So 00587, it's all should always start with a 00, but here sometimes it's yeah, OO or OA. Now, if it's a really simple problem, as for example, it should always start with 0, 0, but then sometimes it appears to be O's or O and A, you can only go for and iterate for the file and basically use regex to check it out. So you don't need AI there. But basically, that's the case if you need the very simple solution there. So let's go back to the response and see. So yeah, here is the prompt that we asked. And cardiological shock is a serious condition that occurs when the heart is unable to pump enough blood to meet the body's needs. This can result in a decrease in the blood pressure, reduce flow, and so on and so on. So yeah, this is exactly what the whole answer exactly provided from our text, and it works. Yeah. So we built the full online our closed source RAG with this.
Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.